We can use another definition of an angle bisector that is much more important than the previous one, which is that an angle bisector is the straight line whose points are equidistant or at the same distance to the lines that form the angle. If we have this line V as the angle bisector of the angle that straight lines S and R form, let's check this property, and we're going to check it with 3 points: point P, point Q, and point R. If we find out the distance from point P to line S and R, the distance will be exactly the same. In order to find the distance, we have to draw perpendicular straight lines from point P to the line we want to find out the distance, in this case point P to line S, and from point P to line R. The distance from point P to point 1 and to point 2 drawn in perpendicular in relation to lines R and S is the same, as you can see. So distance from point P to point 1 is the same as distance from point P to point 2 on lines S and R. Let's check it with point Q. We draw a perpendicular line in relation to straight line R from point Q and we do the same. We draw a perpendicular line from point Q to straight line S and the distance from point Q to points 3 and 4 will be exactly the same. And we can do the same with point R, finding out the distance from this point to lines S and R and checking that it's the same. And the distance from point R to points 5 on a straight line S and 6 on straight line R will be the same. So, as you can see, it doesn't matter which point we choose on the angle bisector of an angle, because every point on the angle bisector is the same distance to the lines that form the angle. We can apply this second definition in order to find the angle bisector of the angle that these two straight lines form. If we find at least 2 points that are at the same distance to straight lines S and R, one of which is point P, the line that goes through those 2 points will be the angle bisector of the angle that those two lines form. So if we draw a parallel line to straight line S at a certain distance, and I draw a parallel line to straight line R at the same distance, the point where they both parallel lines meet will be at the same distance to lines S and R at the same time. I choose one point on the straight line S, the point 1, and I draw a perpendicular line in relation to line S that goes through that point 1. I repeat the operation, and I draw on point 2 on line R a perpendicular line in relation to line R that goes through point 2. Now I take the same distance, the one I like most, from point 1 on that perpendicular line and from point 2 on its perpendicular line. The condition is that it's the same distance on both cases. Now I have to draw a parallel line to line R that goes through the point 2 that I have found previously, and I do the same, drawing a parallel line in relation to line S that goes through point 1. Both lines, R and S, meet in one point that point A. Point A, since it is on a parallel line R' and S' that are on the same distance to lines R and S, the point has to belong to the angle bisector of the angle that R and S form. So the line that goes through points P and A is the angle bisector of the angle that these two straight lines form.